Welcome to MS class. See, today we will discuss about the relation. Okay, till now we discuss about the Cartesian product and ordered pair elements. So today we will discuss about the relation. See how to that whatever the practical life in which we related, that husband, wife, teacher, students. Okay, in this way, some relation in the physical life. The same concept will be used here also. See, here I am taking two sets. One is A, another is B. Here it is written Guwahati, Imphal, Shillong, Itanagar in set A, and set B is Assam, Manipur, Arunachal, Meghalaya. And if we take the cross Cartesian product, what will get? Guwahati, Assam, Guwahati, Manipur, Guwahati, Arunachal, Guwahati, Meghalaya. In this Imphal, Assam, Imphal, Manipur, Imphal, Arunachal, Imphal, Meghalaya. Shillong, Assam, Shillong, Manipur, Shillong, Arunachal, Shillong, Meghalaya, or Itanagar, Assam. In this way we will get. But if I take the relation is that capital of A is the capital of B, A is the capital of B. That is the relation we are taking. A is the capital of B. So that case, how do we write? R is equal to Guwahati. Guwahati is related with Guwahati is the capital of who? Assam. So Guwahati, Assam. Imphal is the capital of Manipur, Imphal, Manipur. Shillong is the capital of Meghalaya, Shillong, Meghalaya. Itanagar is the capital of Arunachal Pradesh. So clearly what we get, R is nothing but the subset of A cross B, subset of A cross B. That means the relation capital of from set A to set B gives rise to subset R. This is nothing but, relation is nothing but a subset of subset of whom? A cross B. This relation is nothing but a subset of A cross B, such that x comma y belongs to R and x is related to y. That is, x is related to y. In any way, x is related to y. So how can you define? If A and B be two non-empty sets, then a relation R from set A to set B is a subset, is nothing but what? Is a subset of A cross B. That is, R is a subset of A cross B. Now if A comma B belongs to R, that is relation, then A is related to B and it is denoted by RAB. It is denoted by what? RAB. And if A comma B does not belongs to R, then what will write? A is not, what will say? A is not related to B and it is written as R not related to B. We will write in this way, R is not related to B. Okay. Next, representation of relation. How will represent a relation? In roster form, we can represent a roster form. Relation is represented by the set of all ordered pairs belongs to the relation. Okay. Set of all ordered pairs belonging to the relation. Suppose A is equal to minus to this, B is equal to this. So R is equal to what? 0, 0, minus 1, 1, minus 2, 4, minus 1, 1, 2, 4. This relation we have written. What is the relation? That A square, first one is square of the second one. Second one is the square of first one. A square. B is equal to A square. B is equal to A square. That is A comma B. B is equal to A square. So 0. This is 0, 0 is 0 square, 1 is minus 1 square, 4 is minus 2 square, 1 is 1 square, this 4 is 2 square. Okay. So all written in the elements, ordered pair elements, that is roster form. Next is set builder form. Set builder form, how can you write set builder form? The relation R from set A to set B is represented as R is equal to A comma B, such that A belongs to A, B belongs to B. A and B are satisfy the rule, some rules. A and B will satisfy some rules which associates with A and B, that rule. Okay, they will satisfy some rules which associate. Now if we see this one is written in the roster form or tabular form. Now if we are asked to write in the set builder form, how do we write? A comma B, says A belongs to A, B belongs to B. What is the condition? A square is equal to B. This is, in this way A and B are associates. Okay. Next is arrow diagram. In order to represents the relation from set A to set B by an arrow diagram, we draw the arrows from first components to the second components of all the ordered pairs belongs to the R. Belongs to the R. For the first component, order the first component 0, -1, -2, 1, 2. Here order the first components. This is the elements of the first set. A is -2, 1, 0, 1, 2. Here B is 0, 1, 4, 9, 10. The condition is what? A square is equal to B. A square is equal to B. So -2 whole square is equal to what? 4. 4 will get inside B. So -2 is related with 4. -1 whole square is equal to what? 1. 1 is inside B. So -1 is related with 1. 0, 0 square is 0. So 0 is related with 0. 1, 1 square is 1. So 1 is related with 1. 2, 2 square is 4. 2 is related with 4. So in this we can draw the arrow diagram for represents a relation. Okay. Next, see domain and range. What is domain and what is range? If R is a relation from set A to set B defined by R is equal to A comma B such that A belongs to A and B belongs to A, this is a relation. This is a relation. So domain of R, how to find out domain of R? All the elements, the set of all elements of the first component, set of all elements of the first component, the set of all elements of the first components of the ordered pairs are called the domain of R. That means domain of R, what will that? A, here A, such that A belongs to A comma A belongs to R, A belongs to A, B belongs to B. That we also can write here. Okay, no problem. Range, what is the range? If the set formed by the first components, that is the domain, and the set formed by the second components of the ordered pair elements, the set formed by the set of all second elements of all ordered pairs of R is called the range of the domain, range of the relation. So range of R is equal to what? B. Range of R is equal to B such that A comma B belongs to R and B belongs to B. B belongs to B. Just diagram we can say this is A, this is B, this is the relation R, and these elements are related to these elements. So the elements belongs to the first components is the domain, and the elements belongs to the second set is the range. Note, here we have to keep in mind that if Na is equal to P, number of elements of A is P, number of elements of B is Q, then total number of subsets of A cross B already got 2 to the PQ, and total number of relations. Relation is nothing but a subset. So total number of relations what will get 2 to the PQ. So sometimes the questions may be asked, find out the total number of relations from a set to another set. That will depends upon the number of elements of the set. Okay. Next, see example. One example I have taken. What is the example? If A is equal to 1, 3, 5, 7 and B is equal to 2, 4, 6 and let relation is equal to 1, 8, 3, 6, 5, 2 and 1, 4, be a relation from A to B, then domain, what will be the domain? Domain all the elements of the first component 1, 3, 5, 1. So once time we will write 1, 3, 5, and the range of R is equal to the second components. What are the second components? 8, 6, 2, 4. So what will write 8, 6, 2, 4. This is the range. In this way we will find out the domain and range. Okay. Next, see the inverse of a relation. Let A and B be two sets and R be a relation from set A to B. Then the inverse of R denoted by inverse of R is denoted by R inverse is a relation from B to A. Here it is A to B and here it will be B to A, and defined as R inverse is equal to B comma A such that A comma B belongs to R, A belongs to A, B belongs to B. Clearly it is clear that A comma B belongs to R if and only B comma A belongs to R inverse. Okay. Note, domain of R is nothing but range of R inverse. Whatever the domain in the relation will get, that will be the range for R inverse relation, and whatever the range in this relation will get, that will be the domain of the inverse function, okay, inverse relation. See here one condition example we are taking. Let A is equal to 1, 2, 3, B is equal to A, B, C, D, and R is equal to what? 1 comma A, 1 comma C, 2 comma D, 2 comma C from A to B. Then what will be R inverse? R inverse will be A comma 1, C comma 1, D comma 2, C comma 2. A comma 1, C comma 1, D comma 2, C comma 2 is a relation from B to A. Okay. Next, see type of relations. What are the types of relations? There are so many types of relations are there. Let us discuss the type of relation. First type of relation is empty relation. What is empty relation? If there is no relation between the elements of a set on a set or a set, element of a set or sets, then the relation is called empty relation. There is no relation. There is R is equal to phi. No elements you are getting. Set phi already got phi is empty set is subset of each and every set. So empty set we may get for relation. R is nothing but what? R is the subset of A cross B. So phi is the subset of each and every sets. So we may get that one. So empty relation we may get. So the relation R in the set A is equal to 2, 3, 5. This is 2, 3, 5. Okay. Given by R is equal to A comma B such that A square is equal to B. A belongs to A, B belongs to A. A comma B belongs to A. Both are belongs to A. But condition is what? A square is equal to B. Condition is A square is equal to B. So we will not get any elements whose A square is equal to B. We will not get. Is there any perfect square number? No. 2, 3, 5 all are prime numbers, but they are not perfect square numbers. So we will not get any type of elements that satisfied the condition. A comma B satisfies the condition that A square is equal to B. So here R is equal to what? R is equal to phi. Okay. So this type of relation is called empty relation. Universal relation, a relation R in a set A is called universal. Is called universal relation if every element of A is related to each of the element of A. Every element of A is related to each and every elements of the A. Then that is R is equal to A cross A. R is equal to A cross A. This relation is called universal relation. Both the empty relation, this both empty relation and universal relations, sometimes it is called trivial relations. Called trivial relations. So which are called trivial relations? Empty relations and universal relations are called trivial relations. The empty relation is the smallest relation. Empty relation is the smallest relation, and universal relation is the largest relation. Okay. Which is the smallest relation? Empty relation is the smallest relation, and which is the largest? Universal relation is the largest relation. Next is identity relation. Identity relation, the relations IA is equal to A comma A such that A belongs to A is called the identity relation on A. As for example, if A is equal to 1 to 3, then the identity relation on A given by IA is equal to 1 comma 1, 2 comma 2, 3 comma 3. Okay. Next, see the reflexive relation. What is reflexive relation? This is the main things, our discussions, reflexive relation. A relation R on a set A is said to be reflexive if every element of A is related to itself. It is almost same as like identity relation. R is the reflexive if A comma A belongs to R, for all A belongs to A. Okay. That's why notice that identity relation is always a subset of reflexive relation. Okay. That means all identity relation is reflexive relation. If A is equal to 2, 3, 5, then the relation 2 comma 2, 3 comma 3, 5 comma 5 is a reflexive relation. Next, symmetric relation. What is symmetric? A relation R on a set A said to be symmetric relation if A comma B belongs to R. If A comma B belongs to R, it implies B comma A belongs to R. For all A comma B belongs to A. here one thing we can say, reflexive, A is related to A. A is related to A, for all A belongs to A. Okay, and here A is related to B, it implies B is related to A. A is related to B implies B is related to A. Then only we can say that relation is symmetric. If 2 comma 4 comma 7, then and R is equal to 2 comma 4, 4 comma 2, 7 comma 7 is symmetric, because what? Why this? If we take 2 comma 4 belongs to R, it implies what? 4 comma 2 also belongs to R, 4 comma 2 belongs to R. So this is reflexive. Okay, symmetric, this is symmetric. Again it is given 7 comma 7 belongs to R, it implies if we change it, then same thing will get 7 comma 7 belongs to R. So this is also transitive. Okay, symmetric. Symmetric means A comma B belongs to R implies B comma A belongs to R. That means A related to B implies that B related to A. Next is transitive. What is transitive? A relation R on a set A is said to be transitive if A comma B belongs to R, if A comma B belongs to R and B comma C belongs to R. A comma B belongs to R and B comma C belongs to R. Be careful, A is related to B and B is related to C. It implies A is related to C. A is related to C. If we get this one, A is related to B and B is related to C implies A is related to C, then R is transitive. Okay. If condition one example, see, if A is equal to 2 4 7 and R is equal to 2 comma 4 4 comma 7 2 comma 7 4 comma 4. Now if we take this 2 comma 4 4 comma 7, so 2 comma 4 belongs to R, 4 comma 7 4 comma 7 belongs to R. This 4 cancel, so 2 comma 7, is it 2 comma 7 belongs to R? Yes, 2 comma 7 we are getting belongs to R. So this is transitive, the relation is transitive. Okay, in this we have to remember the things and we have to use this concept to solve the problem. Okay, and if a relation is satisfied all these things, a relation is a reflexive, a relation is a symmetric and transitive, all these three, then that relation is called equivalence relation. Okay, in the next class we will discuss about the equivalence relation and some problems related to this concept. I think I hope that you understand the things. If any doubt, let me know. I will try to my best to clear your concept. Okay, thank you, have a nice day.